All right, folks. It is time for us to work on our last lab, so I'm ready to go. I got my YouTube socks, and I'm pulling them up, getting ready for that last lab. Also, this time I purposely didn't shave for this segment. Reason I didn't shave is that um, there are some questions that I must stash you about rolling motion. Ooh, all right. So, actually, yeah, maybe I will shave here. Let's see. So, physics teachers like to keep their shavers and their razors in their hats, and so let's see. Oh, there we go. I feel all clean. Okay. Now we are going to have some races going on, and we are going to right over here in my living room. I will actually have an old bifold door set up, and it will be an inclined plane. It'll be angled at just about 15 degrees. And so then we are going to have races down the incline between various objects. The distance will be 1.5 meters. You will see that set up here very, very shortly. And we're going to have a race between various objects. And we are going to do that. We're going to test out these things about rotational inertia and about rolling motion and see, do they actually work in the lab with this. And so we're going to have some fun with that. Our point particle is actually going to be the car. I'm going to explain when I get when the ramp set up, thinking about, well, why is this a point particle? And so we will, that's something we want to think about. I've actually made reference to that before. We're going to have a sphere. This is a solid rubber ball, actually pretty hard rubber. And so we're going to use that as our solid sphere. Our disc is going to be actually a wooden disc that is actually made by a scientific education company called Senko, and so it is just a wooden disc that is made for this purpose. That's actually what the thing is made for. They also make this metal hoop. These two are actually made to be, you buy those from the company, they're made to be the same radius. They're made to be about the same mass as well. And so, but they're for that purpose, but you could use just about anything. These I had with me, so I thought, okay, we'll try those out. And we are gonna also make some measurements on duct tape. All right, so this is something that also, when we get set up in there, I don't want to double too many things up here, because I in the various segments I talk about the things that you want to think about in there, and also in the lab as well. All right, so with no further ado, I want to get ourselves some measurements going. So we're gonna make some measurements, and now we got to be crafty about this. And so I'm hoping this works out nicely, because I'm trying something I've never done before. And isn't that what life is about? Trying new things. And so, although I'm not sure I want to try this pandemic thing again, I could do without that for the rest of my life. All right, folks, let me pause here. And let's get ourselves started on our very last lab. Oh, and do you know what we would have been doing right now? If we were in the lab, I would have carved out time for Foursquare. Oh, and see the dog. Whoever that dog outside is actually upset about that as well. I don't know if you can hear that or not. All right, folks. All right, watch these videos, do this lab, and think about Foursquare. All right, folks, it is a beautiful day here at the races. I have got an old bifold door that was sitting in my garage. I used to hang in one of the doors in my house, but we pulled it off of there. It's been sitting there waiting for this pandemic to be useful again. And so I've got the door, I've got it angled in here. It's a little difficult to see in here, but I've got it sitting up on one of my dining room chairs, and then all around the ground on that side. So I've got it angled at just about 15 degrees. I used one of those angle indicators like we've used in lab before, and got it set at just about 15 degrees. Now the other thing to notice on my door over here is that I tried to make sure it was level in this direction reasonably, so I just brought my level and put it on there. And I've angled it at 15 degrees, and I've put some masking tape on there, and you see those two black lines going across this way, and then I got out a Sharpie and I measured out 1.5 meters in there. And so that is going to be our racetrack going down the incline. So Oh, this is exciting. Yes, yes, yes. But we're gonna do a bunch of different things in here. So let's start with a race over here. So let's introduce the racers that we're gonna have in here. All right. So okay, massing in at 0.506 grams. All right, this is going to be our point particle. All right, now we have treated this as though it is just a particle. And the reason that we have not had to worry about its rotation is the fact that very little of the mass actually goes into rotation. You might have wondered when you looked at this, okay, they make this really fancy car. Why did they put these teensy little plastic chintzy wheels on there? Shouldn't you put some big, nice mag wheels on this so we could cruise down with that? And the answer is yes, that would actually make it roll better, but it would actually, then it wouldn't act like a point particle. And when we did those early experiments where we were just treating it like it was a particle, we would have gotten accelerations that would not have matched that. And so this is designed to have very, very light wheels in there. They're made to be low friction, so they've got very nice bearings in there, but they are, by design, they are small and not very dense. They are nice and light. All right, so won't need as much introduction for the other parts. Okay, so let's see. All right, got a sphere here, and so just a little, it's actually a little solid ball. I don't think you're gonna have to trust me that this is a solid rubber ball in there. So that is going to be our solid sphere. This is made by Senko, so this is actually a wooden disc that is made for this purpose. It's actually made, and they sell it, and they actually sell it with this is going to be our hoop. So this is it's actually a metal hoop, and these are actually made to be just about, same radius and just about the same mass. They're actually made so for these racing purposes, to try to show you that the mass isn't actually a factor in there. But in these gravity problems, we know the M&Ms are going to melt, and we actually see that in the setup of it that the radius in these rolling motion ones does actually cancel out of there. And what ends up mattering is the distribution of the mass, how it is distributed. All right. So now what we need to do is we're going to first do the race between these four. Then I'm going to pause a little bit and set up some other races. All right, so now what I got to do is, all right, so I'll put this here, and I'm going to go over like this. All right, so I've got my starting gate. So this worked in rehearsal. Let's see if I hope it works now as well as it worked in rehearsal. So I got my starting gate, and I'm going to get everybody set up along this starting line in here. And so what I'm going to do is I am going to go 1, 2, 3, and I am going to raise the starting gate. So I'm going to get myself up like this. I'm going to go over like so. All right, here we go. Ready? 1, 2, 3, go. Boom! Did you see it? I hope that turned out, looked pretty good from the direction I was looking at it. All right, and so it is time for us to get swinging on some of the other stuff. All right, I'm going to pause and set up another one.